Welcome to the ITversity YouTube channel, and this is Raghu, and today we have a brand new tutorial on Delta Lake for data engineers. See, Delta Lake is one of the most used file formats today, and a lot of people are very curious to know like how to use it. So in this particular tutorial, we will first start by understanding what is the Delta format. We will also compare it with some of the other popular formats in the industry, for example, Parquet. And then we will jump into the demo where we will be using the Databricks Community Edition, and we will create Delta tables, we will insert the data, we will query the data, we will update the data, even we will be talking about the upsert operation. So this is going to be a complete hands-on step-by-step tutorial which you can watch and learn everything about the Delta tables and how to use them. Now, in case if you are somebody who has not subscribed to the ITversity channel, then please consider doing so before jumping into this video, and let's begin. Hi. So in this module, we will be talking about Delta Lake. Before we jump into the module and the contents that we are going to cover, let me give you a brief agenda about this module. So in this module, we will first start talking about the conventional file formats that we have been using in the world of data engineering. So we have CSV, we have Parquet, we have ORC, so on and so forth. So we will understand what they are. We will also understand what their limitations are. And then we will understand the Delta Lake file format and how this particular file format is much more efficient than the other conventional file formats. And once we discuss this, we will be jumping right into the hands-on part. So in the hands-on part, using the Databricks Community Edition, I will be demonstrating basic operations on Delta Lake, starting with creating Delta tables, different ways to insert the data in Delta tables, and then operations like updates and deletes, etc. on Delta tables. And last but not least, we will be also having a hands-on lesson on the upsert operations on Delta Lake. You don't have to worry, we will be covering all these things in detail. And then I will also discuss some of the industry use cases or real-time scenarios where Delta Lakes are very powerful and much more efficient than the conventional file formats. So with that understanding, let's get started. So before we understand what is Delta Lake, let's have a look at the conventional data formats that is present in the industry. Of course, I haven't introduced the idea of Delta Lake so far, and Delta Lake is nothing but a very advanced file formats. So when you look at these conventional data formats, there are so many of them, but three of them stands out, and they are CSV, Parquet, and ORC. Now, CSV is probably the most common one. Even a person who is not in the data engineering arena should be aware of CSV. So it is a very simple plain text format organizing data in tabular structure. And the advantage of CSV is that it is very lightweight, human readable, and it is compatible with most of the tools. However, there are a lot of limitations for CSV as well. For example, it does not support compression. And especially when we are talking about big data, storage space and compression is really important, right? And CSV doesn't support that. And also the query performance on CSV is very, very poor, especially if your CSV file contains millions or billions of rows. The read operations, or so to call the query operations, will fail, in case of performance when you are using CSV. It also lacks schema enforcement. So needless to say, it is high time that we fix this and come up with a new format. Let's have a look at another format, which is nothing but Parquet. Now, Parquet is a columnar storage format, which is ideal for analytical workloads. What do you mean by it's a columnar storage format, right? See, normally if you look at CSV and all, they store the data row by row, right? One row, then another row, then another row. And Formats like Parquet, they store your data column by column. You may be probably wondering what difference does it make if I store row by row or column by column. See, the intention of keeping this data in any of these formats is that at a later point in time, this data is ready for analytical workloads, such as, for example, visualization, business intelligence, analytics, and all. Now, imagine you have a file where you have some sales data and you would like to probably calculate total sale among different countries. So if you write a SQL query, for example, then you are specifically concentrating on two columns such as country and sale. So formats like Parquet makes your queries run very fast because the query has to concentrate only on that particular column which is stored as a separate file in Parquet. So that is in very simple terms what is columnar storage format. So this seems to be like a plus, and it also offers very high compression rates. This also seems to be a plus, but on the other hand, there are limitations. Let me talk about them, but let's also cover ORC. Now, ORC stands for Optimized Row Columnar Format, and this is again very similar to Parquet in a sense. And ORC also stores your data in columnar format. It also helps you to read the data very faster, and it really works for big data workloads, especially for Hadoop. Now, if you compare Parquet and ORC, they're like very similar. But the drawback of them, both the file formats are also very similar. See, the first problem is both these file formats they do not support operations like time travel. For example, what if you want to travel back to a particular date where you made some changes? What if you want to keep different versions of your data? Then Parquet and ORC doesn't support that. Also, they do not support ACID transactions efficiently. Insert, update, delete operations. And probably if you're wondering why this is such a big deal, then you have to look at the modern day workloads, right? For example, imagine you are looking at streaming data. Let's say you're collecting social media feeds, right? So there can be a lot of small insert operations, and there can be updates, there can be deletes, right? So Parquet and ORC lack this. They don't support ACID transactions. They don't support features like time travel, which means like it is high time to come up with another file format which has these features, and that is none other than our Delta. And we'll talk about Delta in the next lesson, but I hope this lesson is clear. So even though CSV, Parquet, and ORC are good file formats, they have some plus points on their side. They lack the modern day capabilities which are required for analytical workloads, and that is offered by the Delta format, which we will be seeing in the next lesson. Thank you. Okay, so let's talk about Delta Lake. So Delta is a file format which is an extension of Parquet and ORC. Well, it's a file format, and it offers a lot of features which are not present in ORC and Parquet. And Delta is designed to work on the modern day data lakes where mutability of files is required. See, a modern day data lake might have big data, it might even have small files, and there may be requirements to have constant insert, update, delete operations. All this can be handled by the Delta file format. So Delta Lake addresses limitations of conventional formats like CSV, Parquet, and ORC. We already saw that they lack certain features in the last lesson, right? And it meets modern data management requirements, right? So in the modern day, every organization depends heavily on a data lake, right? And a data lake has to support any kind of a file, and it should also support constant inserts, updates, and deletes, which is supported by Delta Lake. And it also offers ACID transactions, schema enforcement, and efficient CRUD operations. When I say CRUD operations, create, read, update, and delete. And we will see this in detail. Now let's look at some of these features offered by Delta Lake. The first one is ACID transactions. atomicity, consistency, isolation, and durability, right? So data integrity is very important, especially when you have complex workflows and multi-user environment. Imagine you are working in a healthcare project or a finance project and multiple users have access to your data. Then you need to have integrity of data, durability of data, and Delta Lake completely supports it. And the second thing is schema enforcement. So sometimes what happens, you might end up having incompatible data types or structural changes. And, Delta Lake prevents errors from these kind of scenarios. And it also allows schema evolution. It allows adding, modifying, or removing columns without breaking existing workflows. So these three themselves are great additions to existing features of other file formats, but the list is not over. Some of the very advanced features of Delta file formats are time travel, efficient CRUD operations, and merge capability. So when you talk about time travel, the idea is you can query historical versions of data for audit trails and analytical comparisons. So accountability is very important these days. And imagine you have a data lineage where, let's say, you're collecting data from somewhere, then storing it in a data lake, and then multiple users might be constantly modifying your data. So Delta file format can remember a snapshot of your data a point in time, or it can even remember versions of your data. So you have this feature called time travel. Using that, you can go to a specific point in time and inspect the data and figure out what was the data at that point in time and who made the changes. And you also get efficient create, read, update, delete operations, obviously. There is also this merge capability, which I will be demonstrating in a hands-on lesson. So I think the merge capability will become very clear if you look at a hands-on lesson. But this is seamless upserts for real-time data feeds and slowly changing dimensions. And what more, it also offers data optimization techniques such as compaction and vacuuming. What are they? So since Delta file format supports inserts and streaming data ingestions and all, over a period of time, your data lake will be full of small files. So using this technique called compaction, which can be either run automatically or you can schedule it, you can combine these small files or compact them so that the query performance will get improved. There is another technique called vacuuming. So if you have old files which are no longer required and that is eating up your storage, using vacuuming, you will be able to efficiently remove them. And in case if you want a sort of like a ready reckoner, a quick overview, this is a detailed table that compares CSV, Parquet, ORC with Delta Lake. And these are all the options or features of these file formats we have already discussed. But I request you to probably pause the video and just have a look at it and, probably understand what are the limitations and understand what are the advantages of using Delta Lake. So in this lesson, we briefly spoke about the Delta file format and we looked at some of the advanced features like time traveling and CRUD operations and all. That's all for this lesson. All right. So let's get started with the hands-on part of Delta Lake. And what we are going to do is we are going to take this step by step. So first we will be creating a Delta table and then we will be inserting some data and then the query, deletion and the upsert operation. So in this lesson, we will be looking at how to create a Delta table. So as you can see, I am inside my Databricks Community Edition and there is already a cluster running, the ITversity cluster. And to get started, I'm going to say new notebook. So I'm going to create a new notebook. Let's call it as creating Delta tables, right? And I also make sure that it is SQL. The interpreter is SQL because these are going to be SQL commands. And then I'm just going to hit on this connect and connect to this ITversity cluster. So we are good to go. Now, to get started, the first thing that we are going to do is we have to create a database. So the command will be create database, and I can say if not exist, and let's call it, I'm just going to say students DB, right? I'm just going to say students DB, and let me run this. Okay, so the database is created. So we follow the same hierarchy. First, we'll be creating a database, and then we'll be creating a table. And of course, once you create a database, you have to use it. So I'm going to say use my students DB. Okay, so I'm going to say use, click here, and that runs. So we are using it. And now we have to create a table. Now, if you want to create a table, right, I mean, you can directly say, okay, create table and the command, but it's always better to do it like this. So what I'm going to do, I'm going to say drop table, let's say my students, that's the name of the students. Sorry, drop table, I'm going to say if exists my students. Okay, and I'm just going to hit the run button here. So what this does is that if there is already a table called my students, it's going to like sort of like drop it, right? I don't have a table by the name, but I'm just, and now let's create the actual table. So to create the actual table, let me see if I can get the command so that I can just copy paste it. And I'm just going to copy paste it here. So this is the command. Let me run it first. I'm going to click on run and let it run. And there is a Spark job being fired. That's it. The table is created. So you can see that the command is pretty simple and straightforward. It says create table, name of the table, that's my students. And then you have the usual suspects here, the column names and the data types, right? But the difference is using delta. So this is the keyword that will tell that, you are supposed to maintain the delta file format. So this is all that is required on supported platforms to create a delta table, right? You have to add using delta at the end. So in this brief lesson, we just got started creating a delta table, and we created a database, used it, and created a delta table as well. That's all for this lesson. Thank you. All right. So in the last lesson, we created a delta table. Now in this lesson, let's see how to insert the data into that table. So I'm going to create a brand new notebook. I'm going to say new notebook. And let's call this inserting data into delta tables, and make sure it is SQL. Let me also connect this to my ITversity cluster. The first thing that we are going to do is we're going to use the database that we have created in the last session. I'm going to say use students DB. Okay, that works. And then let's try to do a show tables here. We should be able to see the table we created in the last lesson. And yes, you have the my students table there. Okay. Now we can see the table, but if you need more details about this table, what you can do is you can say describe formatted and then the table name, for example, my students. And if I run this, you can see a detailed description of this table. And what are the things we can see here? So we can see the, column names and data types, obviously. But below that, you can see the detailed table information. So this is very interesting. For example, you have the catalog that it is using, the Spark catalog, to which database it belongs to, the creator time, last access, type. You can even see the location of the table. And this is in DBFS, user hive warehouse directory. and the provider, etc., etc., right? So to get a detailed information about your delta table, you can say describe, formatted, and the table name. And now let's try to insert the data. And we'll first see how to insert single record, and then we will also do a multi-record insert. So to do that, let's try to insert one record just to check if that works. And what I'm going to do is, let me get it here. I'm going to say insert into my students, that is the name of my table, and these are the column names and these are the values. So this is nothing but a regular SQL statement. This should not be a surprise to you, but as you can see, this statement ran without any problem. So we inserted a single record containing these values into our delta table. So you have the student ID as 1, first name and last name, email, etc., etc., right? Let's try to insert one more record, single record. And so right now we have inserted student ID 1. Let's insert student ID 2. And I'm just gonna run it here. Let me run it. Let's see if the command works. And yes, it works. And this time, no surprises. The student ID is 2, and then you have the first name, last name, email, etc., etc., right? So this is how you can do a single record insert into a delta table. And this is pretty straightforward. If you are fairly comfortable with SQL, then this should be a cakewalk for you. You can also do a multi-record insert. Let me show you an example for that. So to do a multi-record insert, all you need to do is like this. So here you can see I'm going to do an insert into my students, and these are the columns. And then in values, I'm passing the values as tuples, one tuple after the other, right? So you have student IDs 3, 4, 5. And you can see for some of these records, I don't have certain columns available. For example, if you look at this particular student ID 5, there is first name, last name, there is no email. So that is kept as empty. And let me run this. And that's it. We successfully did a multi-row insert. So in this lesson, we covered how to insert the data into a delta table, a single record insert and multi-record insert. We also had a look at the describe formatted command that will give you a detailed explanation or description of your table. That's all for this lesson. Thank you. I hope you enjoy this tutorial so far. If you like this video, consider clicking on the like button and share it with your friends who might be interested in content like this related to data engineering and much more. And let us continue with the remaining part of the tutorial. All right. So in this lesson, let's see how to query the delta tables. So the last lesson, we inserted some data, and once the data is inserted, querying a delta table is pretty much like traditional SQL table queries, right? As long as you're comfortable with standard SQL queries, you should not find any difficulty in querying a delta table. But let's have a look at a couple of examples. So I'm just going to create a new notebook for this. So I'm going to say new notebook and make sure it is SQL. And this is going to be querying delta tables. And just to make sure, I will say use students DB. That's the database. I'll say yes. Okay. And I'm going to add a line here. And let's do a simple select star from my students. And I'm going to run this. And no price for guessing. You should be able to see the output like this. So the select star command basically returns all the records from your table. And let me run one more query. So let's add a filter condition. Select star, let's say from my students, where I'm going to say student gender is, let's say, by gender. And let me run this. You can see that the filter query perfectly worked. Last, let's also try to run a select count star from my students. So the count star query will return the total number of rows, which is nothing but 5. So as you can see, you can run almost any SQL query, and you can even do aggregated queries and other kind of queries as well. But just to prove, we are able to create a delta table, insert the data, and run queries seamlessly on top of that. So in this brief lesson, we saw how to run queries on the delta table that we have created, and that's all for this lesson. Thank you. All right. So in the last lesson, we queried the data in the delta table. Now, in this particular lesson, let's see how to update the data. So to do that, I'm just going to quickly create a new notebook. I'm going to say create notebook, and this is going to be SQL. And let me name this as updating data in Delta Lake tables. Okay, and just to get started, first let's make sure that we are using the students DB, the database that we have created. Let's run this. So it has connected to our cluster and ran it. And now let's look at show tables. So we have this table called students, and if I look at what is inside this table, say select star from students, we do have the data. I mean, this is the data that we had inserted. I'm quite sure that all of you remember that from the last lesson. Now, in order to update the data, let me add code cell here. The way it works is we're going to say update and then the table name, that's nothing but students. And then I'm going to say set, and let's say we are looking at student email, and probably I will copy this because of the lengthy text, right? The email address. So I'm just going to copy this here. Yep. So update students, that's the table name. We're going to set the student email to this particular email ID where the student ID equal to 4. And the action U indicates that it is an update statement. So if you look at student ID 4, you can see that there is no email as such, and we're just going to update this record with an email address. And let me run this. And it seamlessly updates that particular record. So if I want to check it again, select star from students. And if you look at student number 4, now there is an email address, which is obviously visible from here. And let's do one more update. I mean, like, just to prove the point, I'm going to update one more record. So this time we are going to update the record where the student last name is Warrett. Again, it is the update table statement. We're going to set the email and the action is U, again, update. Now, if you look at the last name Warrett, that is nothing but student ID 5. Again, this student does not have an email address. Let me run this. And the update has worked. And just to prove it, let's do a select star from students, and I'm going to run this. And there you go. So you look at student 5, ID 5, you can see that there is an email address right now. So this is how you can do simple updates. You can just mention the condition and you can mention the action to be U for update. And then Delta will take care of updating the records. So in this lesson, we learned how to update the data in Delta tables. And that's all for this lesson. Thank you. All right. In this lesson, let's see how to delete data from Delta tables. So deletion is critical for managing data in Delta lakes, and the Delta lake allows you to efficiently delete records based on conditions. So I'm going to create a new notebook as we do always, and I'm going to call it deleting data from Delta tables. Right? And let's make sure that we are using the students DB. And let's first do a select star from students just to see the data. And here we have the data. And in order to delete, you can give a conditions. For example, what I can do is I can say delete from students where student ID equal 4. And let me run this. And there you go. So you can see the delete happen. Let's do one more and then probably we'll check the final output as well. Delete from students where student, let's say email, and we can use the like clause. Let's say something like it has gov, G-O-V, right? And let's try this. And there you go. Let's look at the final output. Select star from students. So you can see we have only student ID 235, right? The reason for that is the first condition we gave is student ID 4 is gone. So 4 is gone, and student ID 1, if you look at here, it is .gov, whitehouse.gov, right? So that is also gone. So this is how easy it is to delete the data from Delta tables, and this is very efficient as well. So probably if you look at the industry back in 2015 or 2012, we had other frameworks in the big data world, for example, MapReduce, and which did not support these kind of operations. In those days, even if you wanted to record, even if you wanted to delete a single record, the whole data had to be read, and then that particular record will be removed, and then it has to write it back, the whole data, right? Now, with the efficiency of Delta lakes, it is just a cakewalk. So in this lesson, we learned how to delete data from Delta lakes. That's all for now. Thank you. In this lesson, let's talk about the merge or upsert operation in Delta tables. Now, the Delta lakes merge statement allows you to combine insert, update, and delete actions based on specified conditions. And this will streamline data management in a data lake. Now, what does this mean? See, imagine you are working in production and you might have already created a table, let's say a Delta table, and it will already have some data. Now, as in when new data arrives, you want to load this new data to the existing table. Now, if you have fresh records, it's not a problem. You can just insert them, that happens. But sometimes you are getting new data and they might be an update on the existing data, or they might want to delete existing records. So this process is called merge. So merging simply means, on an existing table with some data, you plan to do insert, update, delete with a bunch of records. And this can be done using a condition. And probably if I walk you through this example, you will understand how this works. And the important thing that you need to understand here is that there is this idea of staging tables. Now, this is very common in production, but just to reiterate, it's not possible to load the data as it is to an existing table if you want to perform operations like merge or upsert, right? So we need to have something called a staging table or a landing zone in the middle. So the way it works is you first load the data in this staging table, whatever data that you want to, insert or update or delete. And from there, you give a condition and then load it into your final existing table. So let's pick up an example so that I can walk you through this concept and you will be familiar by the end of this exercise. So I'm going to create a new notebook as we do with every example. And let me call this notebook merge or upsert operations on delta tables, right? That's going to be probably the name of the notebook, right? And just to make sure that we are on the same page, I'm going to say use and our students database. I'm going to say run. And this works. And let's also verify that we have the table. So I'm going to say show tables. And we have the students table. Now let's truncate the table so that we can start fresh. So for this particular demo, I want to show you starting from fresh. So I'm going to say truncate table and students. So that means we are like flushing the data from the table. This table will be empty. And this should do the job. Okay, there you go, right? Now, like I said, the first step here is we have to come up with something called a staging table. Now, I'm going to call this students underscore stg, and this is to hold the incoming data. So any data that you're getting will first land on this so-called staging table. And then from here, we are going to insert, update, or delete records to the main table, right? Okay, so let me create this staging table first. And this is the syntax and all are going to be just like another table. So staging table doesn't have any speciality. It is just another table. So we're going to say create table. And then name of the table is students underscore stg. And then we have the schema. And then we say using delta, right? And I'm just going to run this. Now, if you observe what we have been doing so far, and especially in this example, you can see there is a column called action, and it is of string data type. Now, this column will have values like insert or update or delete. Based on that, these operations are going to work, especially the upsert operations, right? I will explain that. So we have created this staging table, and now let's insert the initial data. So we need some data, right? So we're going to populate the staging table with initial records. So when we are inserting the data to the staging table, we also have to, include an action column. We already have an action column, and that will indicate whether the record should be inserted, updated, or deleted. So let me show you how this works. I'm just going to copy and let's add a new cell. And let me run this. So this looks like a very regular insert command. It is, in fact. So we are inserting into the staging table. So we are assuming this is our brand new data, and we are just inserting this into the staging table. So we have all these columns, but it's very important to remember or it is very important to maintain the values in the action column. So in our example, you can see the action column has values I. That means it is going to be a clean insert. Now from my staging table, if I insert the data to the main table. This is going to go with I, so this is going to be a simple insert. So let's insert the data to the main table as well. And if you are thinking like, oh my God, what is this happening? So many steps are here. I will summarize once we are done, and we're going to do this in 2 videos. Don't worry. Now let us insert the data into the main table. So we're going to do a insert into operation. And this is going to be a very simple command. So what I'm going to do here is I'm going to say insert into students, select star from the staging table. Now remember, students is our main table, and then students underscore stg is the staging table. And to verify, let's look at the data in the main table now. Select star from students, and there you go. So this is the same data that we had in the staging table, right? But that got inserted. Now, why am I being so specific is now we are probably talking about like 5 records, but in the real world, this might be sort of like a data ingestion pipeline. Probably you have source systems, from there data is getting collected, and maybe some sort of an ETL tool pushing the data, right? I mean, this can be huge amount of data. This can be millions of records. Even so, the rules that we follow for the upsert statements are same. The workflow is same. So that is why I want you to be very familiar with the workflow. So let's understand what we have done so far. So we started by truncating the main table. That is because we want to start fresh. And then we created a staging table called students underscore stg. So this is going to be the landing zone, the staging table where all the incoming data will be stored. And then we inserted 5 records into our staging table, and then from the staging table we inserted the data to the main table. Now so far it doesn't create any confusion because we just created sort of like a pipeline that inserts the data. And now what happens is, now again imagine we are getting new data again, then how it is going to populate the main table using this technique of staging table. That's exactly what we are going to see in the next video. So in this video, we created the staging table, main table, and inserted our initial set of records. That's all for this session. Thank you. Okay, so let's continue from where we have stopped. So we have populated the main table. And now what we need to do is we have to truncate the staging table because we are receiving brand new incoming data records, right? So I'm just going to say truncate table students stg. So what this does, this is gonna empty the staging table so that we can get new data and then populate that in the main table, right? And let's insert some new data or new records into, the staging table. So we're gonna have some more data, right? And I'm gonna add a code block here and paste this and run this. Now, if you observe this new set of records, you can see that student IDs are like 4, 5, 6, 7, 8, 9, 10. Remember, in our data, we already have 4 and 5. So there is a student with ID 4, there is a student with ID 5. And so we are again inserting 4, 5, and 6, 7, 8, 9, 10. Now, if you look at 6, 7, 8, 9, 10, you look at the last action column value, it is going to be I because it is a brand new insert. But if you look at 4, look at the action column, it is an U or an update. And if you look at 5, here you can see it is a D, it's a delete basically. Right? And we're going to see how this works, but I just want to give you an idea. So this record is going to be an update, right? So if you look at student number 4, as you can see for student 4, there is no email address. So it's going to update this. And this is going to be a delete for 5. And we're just going to say, so for this record, again, there is no email address. And the rest of the things are fine. And let's see how this plays out, right? So we now have populated the staging table with the action column indicating what should happen if we load it into the final table. And let me add a new code cell here. And now let's perform the merge operation. So there is a special merge command which can be used to perform the upsert operation. And this is how it looks like. So you can see that it says merge into students using students underscore stg. So when you say merge into, that is going to be the final table, students, which already has 5 records, using the staging table on. So we're going to compare the ID column to pick up the records because that contains the unique values. And look at here, when matched and the staging.action D, then delete. When matched and staging.action U, then update. When not matched, then insert star. So let's run this. So what this command basically does, this does the merge or this does the upsert, and we are giving a condition for this. So we are saying that, okay, look at the action column. If the value is D, you're supposed to delete. And if the value is U, then you're supposed to update the existing data. Now it says the number of rows are 7, and you can clearly see number of deleted rows 1, updated rows 1, etc. Let's see how the data looks like now. So I'm going to do a select star from students, and I'm going to run this. Now, very interestingly, what you observe here is you look at record number 4, this particular record, and that was an update. So the email address got updated. So you can see here in our original data, this was the staging data, the ID number 4, we asked to update with an email address, right? Originally, student ID 4, you can see this student did not had email address, and now in the staging data, we had the email address, the record with the email address, and the action column said U. And in the final result, you can see that ID 4 has got an email. And next was ID number 5, right? So you can see here there is 1, 2, 3, 4, then you can see 6, 7, 8, 9, 10. So ID number 5, let's see what was the condition. So if you look at here, you can see here that if the action is D, it's going to be a delete. And if you go up, you can see that there is D, delete for ID number 5. Okay. So this is the particular record, but you mentioned the action to be delete, right? So if you go back and look at the final result, right? Look at the main result table, you can see that the total number of entries are 9, right? And then ID number 5 got deleted, right? So this is how you can perform an upsert or merge operation. And this is very powerful because in the real life scenarios, right, what we are going to see is a lot of incoming data coming, and you might want to perform this. We can also sort this output just to see that. And I'm going to say select star from students order by student ID. Just to sort it, I'm going to run it. Same result, but sort it so we can see 1, 2, 3, 4, 6, 7, 8, 9, 10. No 5 there, right? Yeah. So, I mean, so this is really important because like I said, in the real world, there are a lot of scenarios, not a lot of scenarios. In most of the scenarios, you will have an existing data and there will be incoming data. And if it is just a brand new insert, it is fine. But many a times it might be a delete or an update. So this is the technique which you can use very efficiently to perform the merge or upsert operation. All right. So in this video, we concluded the technique for upsert and merge operation. I hope you will practice this and be familiar with the workflow. Thank you. All right. So in this lesson, let's have a look at some of the real world industry use cases where Delta Lakes can be very useful, right? So let's plan to cover 3 industries just to get started. And the first one is nothing but OTT platforms. Now imagine OTT platforms like Netflix or let's say Amazon Prime. So they have a lot of metadata, for example, user preferences, viewing histories, etc., etc. Now Delta Lake offers excellent support for things like real-time recommendations, right? So Delta supports asset compliance and you can do very efficient CRUD operations, right? So for example, OTT platforms probably wanted to quickly update user preference, the content interaction history, real-time recommendations, personalization. All this requires updates and inserts, and that can be done using the Delta file format, right? And the second area is content management. So most of these OTT platforms or all of them will have a content library and they plan to add new shows. They want to update the metadata, removing expired content. So it's very crucial for an OTT platform to maintain an up-to-date library. So again, there are a lot of insert, updates and deletes. And the third is user analytics. So we have this time travel feature in Delta that allows OTT platforms, for example, to query, let's say, historical data to understand, let's say, user trends over the time. For example, how a particular genre interest has changed over seasons, over years. So they can understand and analyze the data using this time travel feature that is also very, very efficient. So OTT industry benefits a lot from, Delta. And the second is e-commerce. Needless to say, platforms like Amazon and Walmart are part of this. So their requirement will be probably something like constantly changing product inventories, prices, promotions, etc. So how Delta can be very effective here? So first, inventory management. So there is a very effective update and merge capability for Delta that we have seen in the previous lessons. So this allows these platforms to maintain accurate stock levels. They can also manage product information and they can even adjust the prices in split seconds. That might be based on demands or promotions, etc. And the second thing is customer behavior analytics. So it's very important to understand the customer trend and analyze it. So again, Delta has this time travel versioning support. So based on that, e-commerce platforms can analyze historical customer behavior, say purchasing patterns, and they can have personalized marketing campaigns for their customers also. And then a very important point is fraud detection and prevention. Now, this has to be achieved by processing and merging large volume of transactional data in near real time. So the way it works is, let's say a user is trying to, perform a fraudulent activity, and that will be a real-time data, right? And you have to compare this with the historical data of user to understand, whether it is a fraud or not. So the merge operation plays a major role here, and Delta is the best format to do this. And another industry is IoT, the Internet of Things, or sensors and industrial applications, right? So this can be like in industries like manufacturing, logistics, and if you talk about the new age upcoming smart cities, IoT devices generate vast amount of data. And this data is probably generated every second, every 5 seconds. So there is a continuous huge stream of inserts coming in. Now, some of the use cases are, for example, like predictive maintenance, right? So the IoT enabled machines or sensors, which can be deployed in manufacturing, for example, can generate alerts when components are nearing a failure. Right? So Delta format can manage this data. It can update the data as well. The second is real-time monitoring. An example will be smart city. So using the Delta file format, you can manage and analyze real-time data from, let's say, traffic sensors, pollution sensors, to help in, let's say, dynamic city planning, environmental monitoring, etc. And then, of course, last but not least, version control for sensor data. So the idea here is when you talk about sensors, there is a constant influx of data. Every 1 second, every 5 seconds. So there is like a huge millions of inserts coming in. And then you also have to keep a version of this so that you can do a time travel and understand what happened in the past. So for all these use cases, Delta is the go-to format. So in this lesson, we learned about some of the industry use cases for Delta, and that's all for this lesson. Thank you. All right, so we wrap up the tutorial on Delta Lake. Now, what do you think about this entire tutorial? Let us know in the comments. And also, if you want us to come up with any other tech content in the area of data engineering or generative AI, then please do let us know in the comments. And please watch the ITversity YouTube channel and click on the bell icon to enable the notification so that you will be notified whenever we come up with tech content like this. At ITversity, we come up with content like this on a very regular basis, and you can check out our channel for tutorials, hands-on videos, conceptual videos related to data engineering, AI, and much more. So this is Raghu signing off, and I'll see you with another brand new video. Bye-bye.